Okay, so now for an application of curved arrow notation, let's think about formal charges and resonance structures. Curved arrows are super powerful in showing proper resonance structures, but it's going to be very important to make sure your notation is all complete. If you do this, you're going to find that you have lots of visual clues for what's going on, right? So let's look at these. Let's look at this resonance structure. So I've got some oxygen atom next to a double bond, and I'm going to take an arrow. I know I've already got the arrows here, right? But if I say, all right, well, these electrons, hey, they can come down here and make a double bond, and these electrons then will go up there to that carbon, right? They can't go over further because I already have 3 hydrogens here, right? So they can't go over any further, but they can go up to there, right? So if I do that, then I go, oh, look at that. I've got an oxygen with 3 bonds and 1 lone pair of electrons. And so I know I know it's down here too, but so it must have a formal charge of +1, and I've got a carbon with, and that was already a hydrogen on there, right? 3 bonds and a lone pair of electrons. So that must have a negative formal charge. By the way, this is always going to help you evaluate your structures, right? Because if I went from a neutral structure and I introduce a formal charge of +1, then I must also somewhere have a formal charge of -1, right? So it's going to be important to put those structures there for these formal charges there. By the way, this also helps your eyes evaluate how good a resonance structure is, right? So if I told you that these two structures are in resonance with one another, and if I told you one of them was more stable than the other, which one would it be? And you would say, this has a separation of charge, right? 2 minuses. This is totally neutral. This must be the better one. And therefore, this resonance structure is the greater contributor. In other words, this bond here, let me get a different color here. Let me do a highlighter. This bond here is not half and half single bond, double bond. Because this is the greater contributor, this is going to have more single bond character. That's going to be more single bond character. And this is going to be more double bond character. Right? Because this is the greater resonance contributor. Okay? That's going to require some practice. Surely that's going to be very abstract for some of you. So I hope you'll practice it and bring questions to class.